Today we are going to talk about something that sounds terrible just by the name of it.
It's look bad.
But is actually, once you figure out the process, not so bad. And it's called complex fractions, which kind of strikes fear in most people's hearts. Because one, fractions, we don't like fractions that much. And two, then you add the word complex in front of it, which to us means complicated most of the time. That's actually not what complex fractions means. So don't let that name alone intimidate you. Okay? So a complex fraction is nothing more than a fraction or fractions, I'm going to use plural, within a fraction. So a complex fraction is a fraction or fractions within a fraction, meaning my numerator is a fraction and my denominator is a fraction. Okay? Or my numerator has a couple fractions and my denominator has a couple fractions. So a complex fraction is just fraction in a fraction. The problem with that is that's not considered good math. And so we have to find some ways to simplify it. Now I'm going to give you two types of complex fractions. Okay? The first type is where it's just one fraction divided by one fraction. Okay? So when we look at a problem, oops. Don't know what just happened. I don't know how to fix it. What is happening? Let's just undo all that we've done. Okay. Whew. Not cool. Okay, here we go. Whew, there we go. All right. The first type of problem that we have is when we have one fraction divided by one fraction. This is called a complex fraction because in our big fraction, we have a numerator that has a fraction and a denominator that has a fraction. When we do one fraction divided by one fraction, all we're going to do is copy, dot, flop. So copy, dot, flop. When we have one fraction over one fraction, this is the easiest scenario. So we would take and copy our first fraction. Our first fraction is x plus 3 over 2. We're going to put a dot and we're going to flop our second fraction. So I'm going to take 2 over x minus 4 and flop it. And then I'm going to multiply. And how do we multiply fractions? Just straight across. And guess what I'm not going to do, although you should. You can. I'm not actually going to FOIL them. I'm just going to multiply straight across. And the reason is because I want to see if anything could cancel. It's not going to in this problem, but what if I have a common factor in the numerator and denominator? I can cancel them. So I'm going to leave it in its factored form. And this is how I'm going to leave my answer. This is it. Tell me, not terrible, right? That's it. Well, of course it gets a little bit harder. Okay. Now, that only works if it's one fraction over one fraction. Where it gets a little bit messier is when we have multiple fractions over another fraction. So let's look at an example of what that looks like. So if we happen to have multiple fractions in the numerator and the denominator, for example, like 1 over x plus x over y over 1 over y plus 1. This one looks worse. Just how it starts, it looks worse. There are two methods to be able to solve this. And I don't care which method you use. Hopefully one of them sticks and you're like, yes, I like that method. Or maybe you do it different on each problem. That's fine too. And we're going to walk through the methods. You ready? The first method, and we're going to do this problem 2 times just so you can see it. The first method that we're going to use is we're going to multiply everything by the least common denominator, the LCD. So when we look at this problem, I'm talking the least common denominator for the whole entire fraction. So if we were to look at just the top, I'm going to rewrite it down here. If we were to look at just the top, if I wanted to add these two, what would be my common denominator? XY. If I wanted to add just the bottom, and if all I had was the denominator, what would be my common denominator? Maybe it would be better to write this instead of 1 as 1 over 1. What's the denominator here? Common denominator here, sorry. Y, or 1y. If this denominator's y, and this common denominator is xy, what's the common denominator for the whole thing? Well, we need parts of both, remember? We would need an x and a y. My common denominator for my denominator was y. That's accounted for there. My common denominator for my numerator was xy. That's accounted for there. So my least common denominator for the whole thing is xy. Whole thing. Now, this gets a little weird because we make the problem more complicated to start with to simplify it. Here's why. I'm going to multiply everything by that common denominator. Now I'm going to put that common denominator over 1. So I'm multiplying xy over 1 over xy over 1. Okay, remember when we multiply by a common denominator, we can't change the problem. If I reduce this, what does this become? xy over xy, which is 1. So I'm not changing my problem. So watch what happens when I multiply this. It's going to look weird to start, but watch. I'm going to get 1 xy over x plus x times xy over y. Yes, hold your horses. Over 1 xy over y plus 1 xy over 1. Okay, this looks weird. Yes. But
this is ridiculous. Let's do method 2 already.
Let's cancel out things that are alike. The reason we would multiply by a common denominator here is because this x and this x cancel out. And this y cancel out. And this y and this y cancel out. Isn't x divided by x 1? So my numerator becomes this. Y, 1y, plus x times x over the denominator I have in x plus xy.
I'm just going to get messed up somewhere in there. It's bound to have to.
That's my answer. We're done. Now, in this denominator, I could factor out an x if I thought it was going to give me something that would cancel out with the numerator, but there's nothing that cancels out with the numerator, so therefore I'm not going to pull out that x. Most of you will like method 1 better if you can figure out your common denominator. Questions on this so far? No questions. We feel good? Okay. Method 2. I'm doing the exact same problem. So let me just rewrite the problem. We have 1 over x plus x over y over 1 over y. I'm going to put 1 over 1. Method 2 is this. We're going to treat this as 3 problems. First, I'm going to deal with only the numerator. I'm going to pretend the numerator was its own problem. Second, I'm going to treat the denominator as if it were its own problem. And then third, I'm going to put it together to do my copy dot flop. Okay? Good?
Whatever.
So, first, let's do the numerator. Let's deal with this numerator first. So if this were my problem, and the only problem I had, I have 1 over x plus x over y. How do we add fractions again? What do we need to have? Common denominator. So, what's my common denominator for this? Say that again. xy. The common denominator here is xy. So I'm going to go ahead and multiply this fraction by y over y, and this fraction by x over x. Why would I do that? Well, I want a common denominator. So I get y over xy plus x squared over xy, which when I combine those, I get y plus x squared over xy. There's just the numerator. Now I got to do the denominator. I need a common denominator between 1 over y and 1 over 1. What is it?
Multiply by y.
Multiply by y. Do I need to multiply my first fraction by anything?
Nope.
Nope. Just the second fraction by y over y. We get 1 over y plus y over y, which is 1 plus y over y. Good? So now my problem looks like this. Y plus x squared over xy over, oops, that was supposed to be in red. I switched to blue. Over 1 plus y over y.
So now you just flip.
Now I can do copy dot flop. I can copy my first fraction because I have 1 fraction over 1 fraction. Copy dot flop. Now, in this method, there will almost always be something to cancel out. So in this particular problem, I can cancel out the y and the y. They're common factors. So I get y plus x squared and x times 1 plus y. Does that say the same thing as the other answer?
Wait, couldn't you cross out the other y's too?
No.
Well, that's how you find it.
Y plus x squared and then the 1 plus y?
No, because these aren't the same factors. 1 plus y is its own factor, so in order to cancel out anything from this, I need another 1 plus y.
So the x and the y are not together?
Correct. Where
The
are you
1
at? Here?
No, down there.
It can be once I distribute it later.
Okay.
Yeah.
Yeah.
You got there.
Yes.
That is awesome.
Yeah, I water.
Say what?
Yeah, there. Why is that equal 1 on the bottom? That'd be like.
Because if you have a common denominator, if you add 1/2 plus 2/3, or let's do,
Right.
right? You can't add the denominator.
That makes sense.
Yeah? Good question. Any other questions? Okay,
Wait,
go.
so the bottom is like the, what's it called? The denominator.
Yep.
The first one I got. Isn't that what you said for method 1?
Yeah, you could get that. Yeah, if you factored it out.
Yeah.
That's why I just multiplied it in and showed you it's the exact same.
I'm getting confused on the answer.
Okay, I don't care which answer you choose. This is just a factored version of this one. All right, so here's what I want you to do. With your neighbors, try the next example. I don't care which method you choose. With your neighbors, try the next example. I'm going to show you both when we get done. I would like to do both methods. So I'm going to walk you through both methods. The answer is there, so you can check your work. But I'm going to start with method 1. And you do not need to differentiate what method you're using. I don't actually care. It's can you solve the problem? Can you simplify it? Whatever method you can use is fine. So for method 1, the first thing I need to do is find my least common denominator. So if I look at my least common denominator for 1 over x plus 1 over y, and then 5 over x, what would be that least common denominator? Guess what it is? xy. I know my least common denominator here. If I wanted these to have the same denominator, one would need an x and a y, and one would need an x and a y. So even though the numerator just has an x, to accomplish having a least common denominator for the whole thing, it would be xy. So I'm going to rewrite it.
Yeah, I just needed to double that for multiply.
All right. So I am going to multiply everything by that least common denominator of xy over xy. Now, we like to think of this as xy over 1. Might help you to think about it that way. So, in the numerator, I get 5xy over x over, in the denominator, I get 1 times xy over x plus 1 times xy over y. Good? Now I'm going to cancel out. The x's will go away here. The x's will go away here. And the y's will go away in this one. Which leaves me with 5y over, and in the denominator I have 1y plus 1x. I don't need the ones. You can write them. It's not wrong to write them. And I get 5y over y plus x. Now, for those of you that did method 2, I'm going to treat this as 2 separate problems. Whoops. I'm going to treat this as 2 separate problems. So the first problem is going to be the most boring one, is that numerator. And guess what? I don't need to do anything with it because it's already 1 fraction. The whole goal is to get it to be 1 fraction. So that one's done. But this denominator, I'm going to treat this denominator and solve just this. So solving just this one, I have 1 over x plus 1 over y. And my common denominator is xy, so I'm going to multiply by y over y and x over x, which gives me y over xy plus x over xy, which means as a fraction, 5 over x didn't change, and my denominator becomes y plus x over xy. Now I need to copy, dot, flop, and I can cancel out any like terms, and the like terms I have are the x's, which leaves me with 5y times y plus, x.
Wait, so xy plus xy is just,
xy, what?
don't you add them across?
No, to add fractions, remember to add fractions, like if I have 1/2 plus 3/2, I don't get 4/4, right? We get 4/2, because if the denominators are the same, we just add the numerators. So the same thing's true here. That's just a number. I don't know what the number is, but it's the same number. So I'm just adding the numerators, keeping the denominators the same.
That makes more sense.
What questions do you have on either of these methods? And again, I do not care which method you choose. It's really dependent on what you like and what makes the most sense to you. And maybe one problem you do one way and another problem you do a different way. I mean, it may be depending on what you see. Questions on this? Okay. So,